Alright, ladies and gentlemen, this is going to be our next video on environmental science, and specifically going through the carbon cycle and its relationship with greenhouse gases. Let's go through and get started on this next video. So what is the carbon cycle? Well, the carbon cycle is the process in which carbon atoms continually travel from the atmosphere to the Earth and then back into the atmosphere. Now, when we talk about carbon, carbon is foundational for all life. When we think about proteins, when we think about DNA, when we think about the parts of our body, they all contain carbon. Now, this element is also found in our atmosphere in the form of carbon dioxide, and that's what we're going to be centralizing and focusing on most of this video here. Carbon's going to help regulate the Earth's temperature and make all life possible and make the temperature sustainable on Earth. Now remember, the carbon cycle is just describing the process in which carbon atoms continually travel from the atmosphere to the Earth and then back into the atmosphere. So since our planet and its atmosphere are formed via a closed environment, the amount of carbon in this system is not going to change. And this is really what we have to be thinking about when thinking about this cycle. So if we were to go through and look at the carbon cycle in detail, we're mostly going to focus on carbon dioxide in the atmosphere. Now, organisms are going to respirate and they're going to put carbon dioxide into the atmosphere. We're also going to see emissions from factories and transportation go through and place carbon dioxide in the atmosphere. And then we're also going to see natural phenomena such as volcanic eruptions that go through and emit carbon dioxide into the atmosphere. That's the organic carbon. Now, the process of photosynthesis is going to go through and take in some of that carbon dioxide and convert it into water, and it's also going to go through and convert it into oxygen. And then we're also going to see carbon locked into the ground. And remember, this process is cyclical. We're going to see this carbon move from the ground into the atmosphere, back into the ground, etc., and through organisms. So it's important for us to go through and think about this process. Now, carbon dioxide can kind of have a bad rap because it's a greenhouse gas. And all a greenhouse gas is, it's a gas that's going to contribute to the greenhouse effect by absorbing infrared radiation. Carbon dioxide and chlorofluorocarbons are going to be examples of this. Now, the sun is going to radiate infrared heat, and it's going to transfer that energy to the Earth, and the atmosphere of the Earth is going to go through and enable the temperature to stay stable. If we look at the stability of the Earth's atmosphere here, we can see even in the hottest place on Earth, we're only going to reach a maximum temperature of 71 degrees Celsius. And in the coldest place, it's going to be negative 89 degrees Celsius. We're going to see an average temperature on the Earth of somewhere around 15 degrees Celsius, which is super sustainable for life. Now, if we compare that to the moon, which does not have an atmosphere, the moon over the course of one day is going to reach temperatures of upwards of 100 degrees Celsius. And then it's going to, on the dark side of the moon, reach temperatures of negative 170 degrees Celsius. The average temperature on the moon is negative 18 degrees Celsius, and this is because it's lacking that atmosphere. So what we can see from this diagram is that transfer of sunlight energy is key, and the atmosphere is key, and these greenhouse gases are key to trap in some of that heat and some of that energy. However, if we increase the greenhouse gas concentration too much, this can lead to global temperatures increasing, which we're going to look at in more detail now. So when we think about greenhouse gases, all they are gases that are going to transmit that infrared radiation or that energy back to the surface of the Earth. And there's going to be four types of greenhouse gases. The four most common are going to be nitrous oxide, carbon dioxide, which we're talking about now, methane, and ozone. And they're going to make up about less than 1% of the actual atmosphere. So if we compare all of the gases in the atmosphere, greenhouse gases only account for 1%. Now what they're going to do is they're going to go through and again trap in that infrared radiation and allow the Earth's surface to stay stable. So what they're going to do is bounce that energy off of each of the molecules here, and eventually that energy will bounce back to the surface of the Earth. That's what we call the greenhouse gas effect. So the way that I like to think about this is almost as if the Earth was a pinball machine. Some of that infrared radiation is going to hit the surface of the Earth and get reflected back towards space. But the greenhouse gases are going to act as a barrier that are going to again reflect them back to the surface of the Earth. So what that does is it keeps the atmosphere and it keeps the surface of the Earth at a stable temperature. If we were to compare this to the moon that does not have an atmosphere, what we're going to see is almost all of that infrared radiation is getting emitted back into space, and therefore the moon is going to be an inhospitable environment for life. Now again, the issue here is not necessarily the greenhouse gases themselves, but the quantity of the greenhouse gases present within the environment. Remember, they're necessary to keep the temperature of the Earth stable. However, if we increase those quantity of gases too much, what it's going to do is cause the global temperatures to rise above what they are now. Now, climate change can be a really hot topic and really controversial in today's world. But here's the way that I like to go through and think about how we go through and understand how carbon dioxide can affect the atmosphere. So let's say I have a bathtub here, and this bathtub has a certain water level in it. Now, into the bathtub we have 100 gallons per hour of water going through and flowing into it. So 100 gallons an hour go into it. And we also have a hole at the bottom of the bathtub where 100 gallons an hour come out of that bathtub. Now, if we do this, 100 gallons per hour in, 100 gallons per hour out, what we're going to see is the bathtub level is going to remain the same. However, if I were to go through and increase the flow of the water by just 1%, so if we were to go through and take 1% of 100 gallons, multiply it by 0.01, that's equal to 1 gallon. So now I allow for 101 gallons per hour to flow in. What we're going to see is slowly over time, since we're only losing 100 gallons per hour, the bathtub is going to overflow. So an increase in just 1% is drastically going to go through and cause change over time for the water level of this bathtub. Now, when we're talking about carbon dioxide and climate change, even though we're only outputting, humans go through and increase the global input of carbon by 1 or 2%. This 1 or 2% is like our bathtub. It's going to have an effect over time where it goes through and increases the temperature. And the longer we go through and increase that temperature, the longer and longer it's going to go through and compound until eventually the temperature becomes unsustainable. So when we think about the carbon cycle and when we think about humans' input to the carbon cycle, we have to think about that compounding effect of carbon dioxide over time. Because over time, what's going to happen is we're going to see slow increases in temperature, but eventually they're going to reach unsustainable peaks. All right, so this is going to be the end of the video. Did you guys learn? Well, did you learn a couple of things? Did you guys learn about the basics of the carbon cycle? Did you learn about what a greenhouse gas is? And did you learn about how greenhouse gases can lead to climate change? This is going to be the end of the video. We'll see you all in class tomorrow.